All right, so today's project is we're going to be looking at taking some 3/8" tubing and trying to perform a symmetrical bend so that from the start to this center line will be 3 inches, and from this center line to the finish will be 3 inches. But we want to be able to do all of our math so that we can take a straight piece of tubing and cut it to the exact length we need, and then we'll start performing the bends. And when we're done, it should line up to be exactly what we need it to be. In order to approach that, we need to figure out the total length of tubing needed from start to finish. Right? So down here, I need to calculate my total length of tubing needed. To do that, there's a few things that we have to take a look at. The trickiest of them is going to be figuring out the length of this curved section that's in the bend. However, if you look at that, this is part of a circle. If I bring in the bender that's going to perform the job, you can see it has a circle shape, right? Because of that, I'm going to go ahead and bring this up and show you the bender. Camera shows it. You can see the 15 divided by 16R. That's telling us the radius of the bender. If you look to the right, you see the 3 divided by 8 OD. That's telling us that this bender is for tubing with an outside diameter of 3/8 of an inch. Right? But to give you that idea, we're going around the entire circle here. We're only going to bend it part of the way, in this case 90 degrees. But our math here is going to be based on a circle. Right? So I need to know my bender radius, which up here I've already provided to you. The bender radius is 15/16. We just looked at it. For the math, I just shorthand that as BR, bender radius. Right? I have some other things over here, tube radius and tube diameter, that we may or may not pay attention to later. But we're going to focus on, again, the length of tubing in the curve. Right? And that is part of a circle. And that is a measurement of length of the part of the outside edge of the circle, which is known as the circumference, right? So the entire circle would be a circumference, but we only want part of it. The formula normally for circumference is going to be 2 times pi times the radius of that circle will give you the circumference. I'm going to plug in the bender radius because the radius of the bender happens to be the radius of this circle. I'm going to plug that in. So 2 pi times the bender radius. Now, the thing we also need to pay attention to is this bend is going to be a 90-degree bend. So I'm only going to use 90 degrees of the circle, and the circle has 360 degrees. So I'm going to use 90 out of 360. So I can calculate the total circumference and multiply it by this fraction, which should wind up giving me the total length of tubing just in the bend, or what I call the bend curve length, or the BCL. Right? I've done some reducing. 90 over 360, this reduces down to 1/4, or 1/4. Right? The bender radius, what I've done was 15/16. I went ahead and took the 2, multiplied it by that to get 30/16 just to shorten this up. So it's going to be pi times 30 over 16 times 1/4. When I multiply the two fractions together, it comes out to 7.5 over 16. So it's pi times 7.5 over 16, which is going to give me roughly 1.47262. And this is a rounding. This was actually a 1, but the next digit was higher than 5. I'm only going to use 5 digits here. But this is 1.47262 inches, just shy of 1.5 inches. All right, so now I know the length of the tubing in the bend, or the bend curve length. But what I also need to know is from here all the way to here, and here all the way to here. Now this is going to be a little bit easier. I only had to do the math for one side of it because this should be symmetrical. But I want to figure out here to here, right? But if I can figure out from here to here, right, which we know, 3 inches, and take a number that we already know and subtract it from that, which is going to be the bender radius. From here back to here is the bender radius, and that happens to be the exact same distance from here to here. So all I have to do is subtract the bender radius from this 3 inches, and that's going to tell me the length from here to here. So 3 minus 15/16. Okay. 3 minus 15/16 is going to give me 2 1/16. Okay. So the length from there to there is 2 1/16. Because this is symmetrical, that also means that this is 2 1/16 inches. All right. I now have, I'm just going to draw this out and say this is 1.47262 inches. I now have the length of every single part of tubing needed. So I can just go ahead and add those up. 2 1/16 plus 2 1/16. That's going to give me 4 2/16, which will reduce down to 1/8. Right, 4 1/8. Now I can add in the 1.47262, but this is a fraction. This is in decimal form. It's a lot easier to go ahead and add these two when they're in decimal form. And the easiest way is to convert the 1 divided by 8 to decimal, which is going to be 4.125. All right. This is that. Now I can add the 1.47262 to it. And I come out with 5.59762. And this is going to be inches. So the overall length that I need from here to here, here to here, here to here is going to be 5.59762, which is really close to 5.6, which I'm going to go ahead and say we're going to round this to 5.6. With tubing, if you're going to round, always round up. You always want to have a little bit too much tubing than not enough. Right? So we're going to call this 5.6. And I'm going to show you, we need to get this back into a measurement that we can use on a measuring tape or a ruler. So I know I have 5 whole inches, right? 5 whole inches. But I have 0.6. And how I want to break that down into measurement on a measuring tape or a ruler is your typical ruler measuring tape, breaks things down into, you have fractions of an inch, quarter of an inch, half an inch, eighth of an inch, 16th of an inch, and even sometimes a 32nd. Now I'm going to try to maintain as much accuracy as possible, so I'm going to go into 30 seconds. This 0.6 is saying it is 60% of a whole inch. So I can take that 0.6, and if I multiply it by the 32 segments of an inch, it'll tell me how many 30 seconds I need. And the number comes out to roughly 19.2. So this is the number of 30 seconds, right? And again, I'm going to round up. This is higher than 19, so I'm going to round this up to 20. So 5.6 inches is actually, we're going to treat that as 5 20 30 seconds, which of course this will reduce to 5 10/16, which will further reduce to 5 5/8. Right? So the overall length of tubing that I want to cut is going to be 5 5/8. Now because we did some rounding, we're going to get a little bit extra. A little bit, but we'd rather have a little bit extra than to fall short. Okay. So overall length of tubing is going to be 5 5/8. Once I know the length of tubing, I know where I'm going to put my first mark. I've already done the math. It's going to be 2 1/16 inch from the end of the tubing. And if I perform the bend, which I've already done, I could bring in the tubing right here and lay it down for you. Of course, I traced this out, but you're going to see that exactly at 2 1/16 inch is where I put my mark. And then I started the bend. I performed the bend. Bend ended. It finished up. And I wound up with exactly 3 inches from here to here and 3 inches from center line to the end of the tubing. I'm going to go ahead and grab some tubing and show you it from scratch. So here I've just got a roll of copper. Right, you see I'm starting out with a roll of copper. I'm going to grab my measuring tape. I'm going to measure from the right side in this case. I'm going to flip it around and go the other way. And I'm not too keen on starting measurements from the end of a measuring tape, so I'm going to start from the actual 1 inch mark. So all of my numbers are going to be, if it tells me I need to go 5 5/8, I'm actually going to go to 6 5/8. I'm going to do what I call burn an inch. Kind of straighten this out a little bit. End of the tubing right lined up with the 1 inch mark. And I'm going to go to 6 5/8, which might be a little bit easier to do on the other side. Start with the 1. I'm going to go to 6. Make sure that that stays with the end of the tubing. 6 5/8. Now, this marker has a little bit wide, so I'm going to make sure that when I make it, when I mark, I'm marking so that the right side of my mark is where I'm wanting. You can go right, you can go left, it doesn't matter. Just whatever you choose to do, be consistent with all of your measurements. So if I'm going to mark, I'm always going to make sure that the right side edge of my mark is on the measurement. We have our 5 5/8. I've marked it. I'm going to go ahead and get the tape out of the way. And here we have a tube cutter. Okay. I'm going to go ahead and open it up. Inside is our blade. We have some rollers for the tubing to rest on. I'm put it in here. Now I opened it up way more than I needed. But as you slowly bring it in, make sure, hopefully y'all can see this, that the blade lines up with the edge of the mark that you wanted to designate as the measurement. Right? So in this case, if I rotate it around, you can see the blade lines up on the right side edge of my mark. Now, this is copper, so the blade will bite into it quite significantly. With stainless, it will not. Right? So don't just crank down on this handle, righty-tighty, lefty-loosey. I'm just going to bite into it just slightly. And all I'm going to do is score the edge. And as I'm going around, it becomes really easy for it to rotate around. At that point, you just tighten up a little bit, go around some more. And pretty much each rotation, you just kind of snug down on it just a little bit. And with copper, I could make this bite in pretty hard and make this, over in about 3 or 4 rotations, but that's going to potentially damage the end of my tubing. So I'm going to take it nice and slow. There it is. Now the thing you need to pay attention to is I don't know if you can see it, but you can see, grab my pencil as a pointer here, you can see there's like a fine lip of copper that didn't get cut off. Now we have to, both ends might be affected that way. And I have a hand reaming tool here. One side, which is kind of hard to see, give you some lighting. will ream the inside of the tubing, and the other side will ream the outside edge. I'm more worried about the inside edge right now, so I'm going to go ahead and stick this in here. And what it is it's hardened steel, and of course versus copper, harder metal versus softer metal, harder metal wins, right? So it's going to shave off the inside edge of the tubing. Right? So if I bring it back in, you take a look at it. See, we got a tiny little lip left. I'm going to go ahead and try to get rid of that as well. All right. And this is going to serve a purpose later, which I'll point out. I'm going to go ahead and ream the outside edge. And you can see it gets a little shiny around the edges. Let the camera focus where you can see it's been reamed. Right. Again, I'll go ahead and remeasure this so you can see, starting from the 1, it is 5 5/8. Okay. And I know I need to go 2 16 inch in to make my mark. This is the only mark I'm going to make. I'm only making one bend. 2 16. I'm going to start from the 1. So that means I'm actually going to go to the 3 16. Here's the 8th. 16th is right here. And I might want to go ahead and mark this with my pencil. Right? Pencil makes a nice fine line. But you have to be wary that this will rub off from, the oils of your hand. Right? I'm just doing that so I can get this out of the way, and then I'm going to come back with my Sharpie and make sure that the right side edge, because that's what I did to begin with, the right side edge of my mark lines up with that pencil mark that I made. Okay. We can double check the measurement. Always double check your measurements. From the end of the tubing to the right side edge is reading 3 16, but I've burned an inch, so that's 2 16. Bringing in my bender now. Okay. Now, if you notice, I was measuring from this end, and it's already been marked with Sharpie. But if you're doing multiple bends, stuff like that, it's good to go ahead. Hey, make an X over here, so you know that that's where you started your measurement from. I'm going to place the start of my measurement to the left side of my bender. I'm going to open up the arm, slide it in, and what I'm going to do is line the right side edge of my mark right up with the center of the 0 on the radial of the bender. Okay. Now, there are benders that have latches that will latch this in place so it won't slide around. I'm pretty much going to have to hold this in place with these benders until I can bring my top arm down. And a good bender, the 0 on this will also line up with this as well. This is a little loose. It's a little off. I'm more concerned with lining up with this 0. Okay. Once I want to start to bend, I'm going to be bringing this 0 around to this 90. But it's slightly off, right? So you see how it's slightly in front of the 0. So I'm actually going to bring this 0 to it's slightly past the 90. Slow, even pressure. And there's bringing it right to the 90. I'm going to go just past it. Okay. Now, you can see, if you look at it, it looks like I bent past 90, right? But what's going to happen is when I release the tension of this right lever, all metal acts as a spring, so it's going to spring back just slightly. And all of a sudden, now I have a 90-degree bend. All right. So, let's verify that this turned out the way we needed it to turn out. I wanted it from the start to the center line to be 3 inches. I'm going to start from the 1, so it should go to 4. If you look, move this over so it's right underneath the camera eye. The center of the 4 line, which is 3 inches out from 1, exactly 3 inches to the center line. And if I check it this way, like I said, this should have been symmetrical. And mind you, like I said, because we did some rounding, this is probably going to be slightly longer than 3, but that is okay. But it's going to come out rather close. If you look, 1, the 4 is pretty much right in the center of this tubing. So I can say from here to center line is 3, and from here to this center line is 3. If I lay that back over the top of this, it looks like I did get a little bit more than 90-degree bend. But there it is. Single 90 with calculating total length of tubing required, which also involves calculating where your mark is going to go, with a demonstration of using very simple hand tube bender to perform the 90-degree bend.